In this video, I'm going to explain to you what differentiation is in a more overview kind of way, and also tell you how interesting it actually really is, and as well as how we're going to apply it to real life, okay, and solve very interesting questions. Alright, so first we just need to draw two axes of a y and x-axis, okay, and we can then just give an arbitrary function, maybe something like that. Okay, so you know that this graph, whatever this y, which is a function of x, is in y, whatever the value of y is, okay, is affected by the, whatever this value is affected by x, right? So as x changes, y changes. Okay, so as x changes, y changes. Okay, as x changes, it goes more here, y value changes again. Okay, so what you can see here is that this whole graph shows what y is in terms of x, right? And let's use a nicer graph of maybe y equals sin x, okay, which is something like that. And maybe you just take this point, it will be pi, I think, yeah, and this point is actually pi over 2. Okay, so we just take the value from 0 to pi. Okay, and take a look at this graph, y equals to sin x. Now, at the start of the graph, you can see that if I draw a tangent here to this point, just a straight line that's tangent, like perpendicular to the point here, for example, okay, it gives us a gradient, right? And this gradient tells us how quickly something changes. If I take another point here, okay, it's going to be less steep, right? And it tells us how fast something changes. So if I draw this gradient up here, you can see that the purple one is much more steep than the yellow one, which means like that the angle is larger, right? Okay, so the angle is kind of, this purple angle is larger than the yellow angle, which tells us how quickly y changes as x changes. Okay, so if you see at the start of the graph here, you can see that y changes really quickly, right? As x increases a little bit, y increases so much. Okay, while at the end of the graph, as this x increases a little, y only increases a little bit, and just from here to here, just so little. Okay, and so this is what differentiation is about. Okay, differentiation helps us find how fast these things go. Okay, and we can what we've been doing now is to qualitatively explain how y changes with respect to x. So if I'm just saying this is faster, this is slower, okay? But in math, we can use a quantitative analysis of this graph by giving a value to how quick they change, okay? So we represent this value as dy dx. Okay, dy dx, this symbol means how fast y, which is this, y, changes, how fast it changes. The change, d means the change, right? So change in y divided by change in x. So you're seeing how fast y changes with respect to x. Okay, but the thing is, in real life, you see that, for example, if I don't express something, a change, right, I have to express it over an interval, right? Interval meaning this range. So I say that, okay, from here to here, the increase is this much, correct? And even if I want to do something that's decreasing, I have to say from here to here, the change is this, alright? But this that actually just means that it's kind of abstract, you know. It's telling you the change from here to, well, technically the same point here is this. Okay, so we humans need to visualize changes with two differences, right? As from here is to here, you need to see 2 points and you find a difference. That is algebra, but in calculus, which is where differentiation is, okay, we kind of just find how instantaneous, you know, at that point, how much the change is going to be. So that really isn't a change at that point, but we can see how much is going to change. So for example, for the same sin x graph, which I'm going to replicate here, okay, at this point, though I'm not going to compare it anywhere else, it is instantaneous. Okay, at this instant, the change is this much. Okay, and differentiation can do that by using mathematical models, which is very interesting, right? I mean, we humans cannot visualize a change like that, because it's at like 0, right? It's like no change, but there is. Okay, and so differentiation is able to do that. Okay, in this video I'm not going to tell you how we use differentiation to do that, okay, but I'm just going to show an example how we use differentiation. Alright, so you're using the same graph, this y equals sin x graph. If you learn differentiation, you know that this value of the sine graph, how y changes with respect to x, is something like that, right? It's telling us how sine x, the y is just equal to sine x, right? So I just have d, okay, the change in sine x over x. So how sine x changes as x changes, right? Which is how y changes as x changes. So you get this answer. Okay, just know that it's like that first. Okay, in future videos I'll tell you why. So we know that dy dx is equals to cosine x. So for example, if I want to find normally, let's say I want to find what the value of pi over 4 is. So for example, let me use this sign. Let's say I say, okay, we have pi over 4 here. Okay, what is the value of y? So we just sub into this equation, right? So y equals to sine of pi over 4, and you get a certain answer here. Okay, same in differentiation. If I just sub in the value of, for example, let's say I want to find the gradient here. Okay, I want to find a gradient here. This part, see what I'm shading here. That gradient, I just need to find the x coordinate of that gradient. Okay, which in this case is pi over 4. Substitute it into the dy dx equation. So the dy dx equation is cosine x. I just put in cosine pi over 4, and I get a value. Okay, and this value, which I'm going to type in my calculator, is equals to root 2 over 2. Okay, and this is the gradient of the point of pi over 4. Okay, this is the gradient of the point pi over 4 in the graph sine y equals to sine x. So as I move along the graph, I just need to substitute in different values. Okay, for example, if I try a value here, maybe this value, maybe it's purple. Okay, this value, let's say this value is 3 pi over 4. Okay, to find the gradient, which is the gradient, which is how fast it changes, I just substitute in cosine of 3 pi over 4, which is equals to, if I type into my calculator, will give me negative root 2 over 2. The negative sign means that how y changes with respect to x, how y changes as x changes, is that y is decreasing as x increase, right? So you can see it here, right? It makes sense. From at this point, where y is kind of decreasing afterwards as x decrease, right? Yeah, so this is how differentiation is. Okay, we use dy dx to find the gradient of a certain point, and this is how we use the equation. So having the equation, we just need to substitute in the value of each where the point is. Okay, for example, if I find pi over 4, I substitute in pi over 4, I get a value, and that value is used to know the gradient. Okay, so the reason why we want to use differentiation in our lives is because it's very useful to help us solve very complex questions. Okay, so for example, if I have this maybe profits according to quantity of apples. So let's say you're a fruit seller, you're selling apples, and somehow given some conditions, you're able to craft a solution, an equation as to how profits change with respect to quantities of apples sold. So and when you plot the graph out, so remember profits is equals to the function of maybe quantity of apples sold. Okay, and you maybe get a interesting shape, maybe like that, right? Okay, and you want to maximize your profits, right? So you got to find where this point is, because it's the highest, right? And then you need to find so you want to sell the amount of apples where at this quantity, right? So that you get the most amount of profits. You know, so how you find this, okay, is, if you don't have a computer to solve it for you, you need to use differentiation. Find a point where the gradient is 0 and find the x value. But you can see that there are many points here that are 0, right? So again, you need to find which point is the highest. And all you can do this, you can do all of this with differentiation. Alright, and this is really important. Okay, so even if you're not doing like engineering or science in the future, having this knowledge of differentiation and integration is super useful to your life. Okay, and in the fields of engineering and science, differentiation is super important because, like I said, we humans cannot visualize instantaneous things. Okay, we need to compare things over a certain period of time, like velocity, acceleration, and kind of things. Okay, and in physics and whatever science, engineering, you need differentiation, okay, to help you explain objects, how they move, the motion. Okay, and so I hope in this video you get an idea of what differentiation is, okay, why we even use it, and what's the purpose of differentiation. Okay, so do look at the future videos I have that I will be making on how we do differentiation and the techniques of differentiation.